Okay, so for this video, ang gagawin natin is pa-perform na natin yung actual na design. So I would like to urge you to watch yung precursor ng video na to. So yung previous na video doon sa list, doon sa ating module. So pakitignan yun kasi andoon yung discussion regarding sa mga inputs na gagamitin natin for this part of yung discussion natin. Okay, so diretso na tayo sa design. So make sure na kompleto na yung analysis details natin dito. Now, to perform yung design natin, kailangan nating identify yung code. So as mentioned dun sa previous video, we're going to use AISC 36005. Yun yung basis kasi ng NSCP. So, by the way, paano ba pumunta rito? No? So, if you're under loading, pupunta lang kayo ng analysis. And then, still design. Right? And then, papalitan natin yung current code ng 05. Right? Ito yung ating input panel. So, left to right yung process. So, what I mean is, we will start by selecting the parameters, defining the parameters, and then followed by yung command. Tsaka natin ipo-perform yung actual design. So, ang ilalagay lang natin dito is basic muna. Yung wala munang checking and whatnot. So, basta basic lang na analysis. Ay, na design. Perform lang add lang tayo ng parameter, i-design lang natin. That's it. So, yung optimization and checking will be placed on another lecture para mas ma-designate natin maigi yung time natin. So una tayo dun sa select parameter. Default na lahat ng parameter na available ay selected. If you do not want some of them, you can just deselect them. So pwede nyong dalhin dun sa may left side para mawala dun sa ating selection. Let's not do that. Ka-cancel natin. Right? So, we can now define yung mga parameters. But before we proceed with yung define parameters, i-specify muna natin yung code or yung design type na gagamitin natin since still. So for this example, LRFD yung gagamitin natin. And take note na yung load combination natin naka-specify lang na 7 to 19 yung LRFD. So doon sa may loading setup natin, yung ginawa natin na load combination, 7 to 19 yung 7 to 19 yung LRFD. So before we proceed with yung actual definition of parameters, alright, kailangan muna natin gawin yung load case or load listing muna para ma-identify kung ano yung load combination na gagamitin ng design. So mag-load listing muna tayo. That will be number 7 until number, isi-shift natin doon sa keyboard. So ipipress yung shift and then 19 towards the right side. So from 7 to 19, I'll press OK. We can actually define envelopes pero as far as yung requirement is concerned, hindi na I really do not like using envelope for this for yung process ko, yung workflow ko. So load list will work just fine. So load list, check natin doon. So miscellaneous, sa post-processing, post-analysis pala. Definition, so 7 to 19. Alright, and then pwede na tayo mag-proceed sa still. Ibalik natin yung current code natin ng 07. I-define natin yung mga parameters. So dito ko na lang ilagay. So ano yung mga gagamitin natin? Wala tayong angle bar, wala tayong single set, unsymmetrical. So hindi ko lalagyan ng axis. Okay, wala yan. I do not want to overburden my software na mag-design or mag-check ng 13 nodes. So, default lang yung aking checking. Beam natin will be 0. I-add natin for sure. Racing, maglalagay tayo ng dalawa. Relative and then nodal. Okay? Andito siya. Cantilever, wala tayong cantilever. Okay lang yan. CB, i-define natin na 1. Naka-default na actually. So, wala naman tayo ditong mga member na medyo... Kung meron kasi tayo mga member na katulad nito, like for instance, yan, may joint yan, tapos mainframe yan, tapos meron kang bracing na ganito. K-type. So, medyo hindi natin pwedeng gamitin yung CB na 0. Kasi yung computation ng CB for yung beam na to, na main beam, it will be different. So, supposed to be, dapat parehas sila. So, either i-compute natin manually or we'll just set yung value to 0. Conservative lang. Well, anyway, so since wala namang ganun na set na condition, or kaya another example is yan, yung mga main beams natin, tapos frame yan, and then meron tayong intermediate dito. Kita natin yung kulay. Isang beam lang to, itong portion na to. Pero yung computation kasi ng CB will be different kapag ginawa natin na CB na 0. So, if ganyan yung setup, we'll just assign 1. Pero dito kasi wala tayong problem. No? So, I'll just use 0. CB na 0. I-add natin yan. Nandito siya. Next. Wala akong checking ng spacing ng connector, so I'll skip this one. Deflection check, I will ignore deflection check. Hindi ako maglalagay nito. D max D min, wala rin akong limitation, so okay lang. I'd rather choose IMF, intermediate, kasi yung framing natin, inassume natin na intermediate yung isang direction. So might as well use IMF instead of yung SMF. So ito yung gagamitin ko. Yan. FU value, let's assume 414 megapascal. And then yung FY natin is 24800 or 8,000. 248,000 na yield strength. Okay, hindi ko masyadong, hindi critical yung portion na to. Naka-default na yan sa 0, so I will skip yung interaction checking type. I can use yung tabulation, I can use yung based dun sa discussion natin from yung previous video, we can use yung approximate o kaya pwede tayong gumamit ng alignment chart. I might as well use yung recommended dito. So, yung recommended value. So, yung support ko is nakapin. So, gagamitin ko to sa column. The rest, ang gagamitin ko, just use 1. So, mag-assign tayo ng k-value na 2. Okay. So, k-value for x, y, and z. Supposed to be yung ating k, i-default natin na 1. Yung y tsaka z lang. Gamitin natin yung value 2. Ito rin 2. Wala tayong angle, so skip natin yung leg. LX, wala tayong problem sa LX. Ang common kasi na problem sa LX is kapag ganito, meron tayong mga split connection. Yan. Yung mga L value. So kapag ganyan yung case kasi and we want na yung slenderness is checked across this distance. Ito yung length na i-consider natin. Kailangan nating i-define talaga to. Pero wala tayong problem so far, so na katulad ng illustration natin. So, skip natin yung L values. Okay, main compression, ano yung nakalagay sa code? 200. So, i-add lang natin yan. Main T is 300. Check natin dun sa ating notes. So, ano to? Compression 200, yung tension 300. So, tama nga. Okay, ang method natin is LRFD, add. M-type, maglagay tayo ng beam tsaka column. We'll skip NSF. Profile also. Ratio, let's just retain it to 1. So, I'll skip this one. Naka-default na yan sa 1. So, hindi ako gagawa ng iteration, later on na lang natin gagawin yan. Seismic. Oops. It should be 1. So, sorry. I-edit natin. Modify natin. Dapat naka 1 yan. Yung seismic natin. I-check natin yung seismic. SLF, I'll ignore this one. Wala akong shear lag. I-assume ko na wala. NSU also, I'll just ignore this one as of now. Stiffener, ignore ko rin kasi wala pa akong provision ng stiffener. Okay, ito rin. So, wala pa akong provision ng connection, so hindi ko pa na-identify kung anong gusto kong connection. So, pwede naman, initially, ignore muna natin yung mga check nito. So, meron na tayo ng T-main. TND, ignore din natin yan. Track is, sabihin na natin 2. UB, UT is, ignore din natin. And then, finally, yung weld type. Ignore din natin. Hindi pa natin sigurado kung bolted o kaya kung welded. Now, once that's done, i-assign natin sila lahat. Okay. So, isa-isahin natin kasi ang dami. Ano ba yung beam? Beam 0. That is yung location. No? So, I want na node to node lang yung checking ng design. So, i-assign ko yung beam 0 sa lahat. Assign to view. Still naman to lahat, no? So, okay lang. Bracing. So, meron tayong BR1 and then BR2. BRC1, BRC2. Yung BRC1, relative. And then, ito is nodal. Asan ba yung mga may bracing? Ito sila. So, I'll consider them all as braced number 1. And then, the rest, consider natin sila na BR number. Yan yung problema dito. Yan, check natin yung highlight. Assign, yes. CB, value, to all of my, so I will allow the software to calculate the value of CB for the entire section or entire structure. Frame type, lahat na rin. I-assume natin na IMF. FY tsaka FU, FY, LD, pare-parehas yan, lahat na lang. Yung value ng K natin, for column only. Okay, yung key value kasi dito, yung assumption natin is reset. Saan ba yung nodes natin dito? Ito. Okay. Yan. So, pang column lang kasi yun yung configuration ng columns natin. Fastest way to do this one is select beams parallel to Y. I-assign natin yung KY and then KZ. Main and then T main, yung slenderness check for compression and tension. Normally, kapag alam mo kung saan yung compression and tension, dun dapat i-assign. Pero, never mind, let's just assign it to all. I-assign natin sa view. Oops. Design. Okay. So, assign to view. T-main, assign to view. LRFD is automatic na yan. Beams and columns. So, ganitong gagawin ko para mabilis. I-assign muna natin yung number 2 columns. MTY column. So, I'll select beams parallel to Y. And then, i-assign natin yan sa selected node, beams. And then, ang susunod dito is select inverse. So, beam inverse selection. Lahat ng mga hindi columns, lalagyan natin ng MTY number 1. Oops. Ulitin natin. Beam parallel to Y, inverse. I-assign natin yung MTY number 1. Okay. What's this? Seismic. On all of my members to view. And then, track natin lahat. Should we track all? Mag-assign lang tayo ng isa para hindi masyadong marami. Assign to selected beam. So, yung column na to lang. We're done with yung parameters natin. Pwede na tayo mag-proceed sa commands. Yan. So, basic lang muna. As of now, check code lang muna tayo. Check code for the entire structure. Right? So, everything is set. We can now save. And then, i-perform natin yung analysis. So, punta tayo sa analysis design. Then, run analysis. Then, let's just wait until yung matapos yung analysis. O yung calculation. Alright? And so far, mukhang walang problem. So, yung still design can be found dito sa may option na to. Still design. Yan. So, may mga warning siya. Ito yung sa bracing kasi HSS yung ginamit natin. For now, ignore muna natin yan. Warning lang naman. So, andito yung indication. So, one way to check is andito yung mga indication. Pass, pass. Kung pasado or hindi. Right? So, hindi masyadong intuitive para sa akin yung report dito. Hindi mo rin ma-check kaagad, no? So, mukhang wala namang problema doon sa result natin. So, check natin sa warnings. So, may problem doon sa may HSS. Warning, hindi problem. So, ignore muna natin yan for now. Ang gusto kong i-focus is, pwede tayong pumunta doon sa may post-processing. I-apply natin lahat yan. And then, yung still design can be found under layouts and then utilization. Okay? So, anong gamit ng utilization? Dito nakasummarize yung design result natin for steel. This is only applicable for steel, by the way. So, ang titignan lang naman natin dito is kung pass or fail. So, yung all, and then may another tab tayo dito for failed members. Kung walang laman yan, ibig sabihin pasado lahat. The only thing that you'll do is yung allowable ratio. Ito yung ratio na yung tinutukoy natin kanina. Naka-default sa 1. So, yung actual, and then yung normalized, ito yung titignan natin. Ito yung kino-compare dun sa number 1. If this value exceeds yung allowable, mag-fail yung section natin. Now, another thing to take note is meron tayo dito ng load case na yung pinaka-critical. And as you can see, nakalimit lang sa 7 to 19. So, hindi siya gumamit ng ibang mga load cases kasi naka-list tayo. Alright? So, another thing to take note here is, kung mapapansin nyo dun sa mga ratio, the more na mas malapit dun sa may allowable ratio, the more na mas lumalapit dun sa failure condition. Pero for as long as hindi lumagpas dun sa failure limit natin ng 1, safe pa rin, pasado pa rin. However, ang problem naman is kapag sobrang liit yung ratio natin, hindi rin naman maganda yon, uneconomical yon. So katulad ng mga to, 0.02, sobrang liit. 0.02, ito mas malala, 0.014. Considering na yung ating section kasi, remember na pag nag-3D tayo, ayan, masyadong malalaki yung ating mga members. So it's obvious na malaki masyado yung linagay natin ng parameters. So like I said dun sa unang part ng ating lectures na it doesn't matter because if we are going to let the software run by itself, it will eventually provide us with yung proper na or yung better na value. So, for now, hanggang dito lang muna tayo. No? So, i-summarize lang natin yung na-discuss. So, when it comes to yung performing still design, ang unang gagawin is to balik tayo dun sa analytical design. Ito yung sequence lang. Right. So, ito yung sequence. Kailangan nating i-define yung load list natin to identify yung mga load combination na gagamitin. I-identify or i-provide natin yung parameters and then mag-assign tayo ng command for check code and then we're done with yung basic na design, still design. I forgot to mention also balik tayo dun sa post-processing. Ba't ayaw niya? Layout, utilization, and yung mga numbering pala natin dito, ito yung ratio value. So like dito, yung 0.0414 is yung ratio, yung actual ratio. So kung ayaw nyo na nasa tabulation, you can refer dito sa may UI illustration. Pero may mga overlapping kasi. Subukan nating i-move. Ayaw niya. So anyway, may mga overlapping so hindi masyadong makita ng maigi. Another thing is kapag dinouble click natin dun sa member, meron tayong additional na information dito ng still design. This is one way to check also, one by one, yung result ng design. Yan, still design. Saan pa ba? Still design. Then naka-indicate doon kung pass or fail. Yan, pass or fail, pass or fail. And I guess yun lamang for now. Next is we will perform yung optimization sa susunod na video.